In this video, we are going to learn how to solve problems involving solution stoichiometry. So stoichiometry really applies to different scenarios, different kind of reactions, including stoichiometry. But what is different right here is we are going to be using molarities, which we've learned about in an earlier video, which represents moles per liters, in addition to volumes and moles, to determine either a volume of a certain reactant or product, to determine the molarity of a certain reactant or product, or determine the mass of a precipitate in a precipitate reaction. So let's start with the first example and look at what it asks. In this example, it says how many milliliters of 0.150 molar silver nitrate are required to completely react with 175 milliliters of 0.0855 molar of potassium chromate. So this is part one of the question. And then part two asks, let me highlight a different color, what mass of silver chromate is formed. First things first, since this is a Stoic type of problem, we need to start by writing the balanced chemical equation. So for the balanced chemical equation, we have here silver nitrate plus potassium chromate will give me silver chromate, and this is a precipitate, plus potassium nitrate. And then I'm going to balance it. So we can put 2 right here and then 2 right here. And then let's see. So we need to calculate how many milliliters. So we're given the milliliters of, we're giving the molarity of the silver nitrate. And then we need to calculate how many milliliters of this particular solution of silver nitrate is required to react with this volume and molarity. So the first thing is I'm going to start with calculating the moles of silver nitrate that react with potassium chromate. So I can see here that if I have 175, so here I'm trying really to extract the moles of silver nitrate, okay, times 0.0855 moles of potassium chromate in 1,000 milliliters. You can also, it's completely fine to write this as 0.175 liters, and this can be 1 liter. Both are correct. Times 2 moles. Okay, so now we are using, this is why I had to write the chemical equation, because we're using the stoichiometry. So we have for every 2 moles of silver nitrate reacting, I have 1 mole of potassium chromate also reacting with it. So in this case, I can say 2 moles of silver nitrate over 1 mole of potassium chromate. And this gives me 0.029925 moles of silver nitrate. Now let's track our sig figs. Here's 3 sig figs, 3 sig figs. This right here is exact. And then so my lowest number of sig figs is 3. Okay, then I'm going to proceed from here and then calculate the milliliters using the molarity of this solution, which is the 1.150 molar. So in this case, I'm going to copy and paste this guy over here. And then say silver nitrate. And then I'm going now to flip this over because I want to end with the volume on top. So I'm going to say 1,000 milliliters divided by 0.150 moles of silver nitrate. And this should give me 199.5 milliliters. Okay. And now we need to track our sig figs. The lowest sig figs here is going to be 3. And since we have a 5 after the 9, I'm going to round it. So it's going to be 200. And then I add a decimal milliliters, or you can write it as 2.00 times 10 to the second milliliters. Now let's look at part 2 of the question right here. What mass of silver chromate is going to be produced? Now, again, I can start with the volume that is given to me, the 175 milliliters, okay? And I will basically do the same thing right here. Okay, so I want to switch to moles of silver chromate, and through the moles of potassium chromate, I can then switch to the moles using the equation to the moles of silver chromate using the equation, and then switch to mass using the molar mass of silver chromate. So I'm going to say that is 175 milliliters times I'm going to copy and paste it right here. Okay. Times, now let's look. For every 1 mole silver chromate produced, I have 1 mole of silver chromate consumed. So I can say it's a 1-to-1 molar ratio. 1 mole silver chromate over 1 mole of potassium chromate. And finally, I want to switch to mass because it's asking about the mass. And if right here, I can tell you, because we're discussing this together, that this mass is going to be in grams, and then 331.74 grams silver chromate over 1 mole of silver chromate. So this is multiplying by the molar mass. Let's track our sig figs. 3 sig figs, 3 sig figs, and then 4. So the lowest number of sig figs is 3. So in this case, it becomes 4.96365975 grams of silver chromate. And then I'm going to round to 3 sig figs, so it is 4.96 grams of silver chromate. All right, now we have done a problem. I want you to pause your video and move on to the next problem while I work on it and try to figure out what this question is asking. So this question asks, we have here a reaction that is written out for you, balanced, and if 15.9 milliliters of lead 2 nitrate is added to an excess of sodium iodide to produce 5.61 grams of lead 2 iodide, what is the initial concentration in moles per liter? So remember, the brackets right here indicate that the concentration is moles per liters. Of the original, or in the original lead 2 nitrate solution, and you're given the molar mass of lead 2 iodide. So the first thing you want to do is you want to determine the moles of the lead 2 nitrate, okay? And we can determine the moles of lead 2 nitrate by working it backwards using the mass of lead 2 iodide and the mole to mole ratio of lead 2 iodide to lead 2 nitrate. And luckily, it's a 1-to-1 molar ratio, so it shouldn't be too bad. So I'm going to say here, I have 5 point, or let's determine the moles of lead 2 nitrate. And we can say that I have 5.61 grams of lead iodide, lead 2 iodide, and then times 1 mole of lead 2 iodide. So here I'm dividing by the molar mass, which is 461.01 grams of lead 2 iodide. And then, as we agreed, it's a 1-to-1 molar ratio. So for every mole of lead 2 nitrate consumed, I have 1 mole of lead 2 iodide produced. And this should give me right here 0.01216893343 moles of lead 2 nitrate. Now let's track our sig figs. I have 3 sig figs here, 4 sig figs. So in this case, it becomes 3 sig figs. Now the next step is I'm going to determine the moles of nitrate, and finally I'm going to solve for the molarity. So I'm going to say here step 2, determine the molarity of the nitrate ions. Okay, so to determine the molarity of the nitrate ions, I'm going to take this number right here and start with it. And I can say lead to nitrate. Okay, now I want to switch from the number of, or the moles of the nitrate anion in 1 mole of lead 2 nitrate. So I can say that there are 2 moles of nitrate ions in 1 mole of lead 2 nitrate. And this should give me 0.02433786686 moles of nitrate ions. Okay, now again, let's track our sig figs. Okay, these are exact. Okay, so infinite sig figs, infinite sig figs. So we have still 3 sig figs right here. And then finally, the molarity of the nitrate ion. I will take now, so we started with a 15.9 milliliters of solution. So I'm going to take here the moles of nitrate ions. Okay, so I'm going to say this is nitrate ions divided by the 15.9 milliliters. But remember, molarity is moles per liter, so I have to switch to liters. And then through multiplying by 1,000 divided by 1 liter, this should give me 1.53068345 molar. And again, tracking my sig figs right here, I have the lowest is 3 sig figs. Therefore, I can round to 1.53 molar.